So what we're going to do as we approach this topic, I'm going to call, for lack of a better term, Epistemology 101. We're going to get right at the basics of this. Epistemology is simply the study of knowledge in terms of its scope and its limits. And how do we know anything? How do we learn anything? Let's talk about that for a bit. When we were very, very small and in a playpen, our world consisted of that playpen. That was our boundaries that we could deal with. In that environment, we got a little familiarity with acoustics, visual colors, touch and textures, three-dimensional perception began to take place, basic motor skills to be able to reach and pick up and so forth. Then as we matured, our world broadened to our playroom. Our universe expanded within the confines of our playroom. So we began to have more discernment of things. We began to get introduced to rules and an order to our routine. We faced increased challenges of things that we could deal with, but also increased hazards. Hopefully, with adequate supervision, nothing serious occurred. So as we matured, our next boundary was expanded to our homes. And there we had increased mobility and challenges. We had, again, hazards and even potential disasters if we failed to be responsive. And more and more, subjection to guidance was essential as we had the mobility of our home. Pretty soon as we go further, we got to school and our universe began to expand. We had even more increased mobility and challenges, increased hazards. Subjection to guidance was even more essential until we finally were members of the community. And we had to learn how to handle unanticipated events. And we more frequently encountered things that were less predictable. And we had to start qualifying our sources of guidance, not just our parents, but others in whom we could place or shouldn't place confidence. And of course, as we matured as adults, our universe expanded to the world itself. And again, more and more, it was incumbent upon us to qualify sources of information about the world that we live in. And ultimately, of course, we're now facing the cosmos itself, the universe in some much broader sense. And so, now as we went from the playpen, our epistemology was very heavily influenced by trial and error as we tried things and tried to learn from them. And we began to get some internal processing of what we were learning and, of course, getting some external guidance. As our boundaries expanded, our trial and error became less a percentage. More and more we had guidance. And as our boundaries continued to expand, the trial and error mode of our gathering information decreased, and our internal processing and external guidance becomes more and more paramount until we get further and further to where finally facing the cosmos where the trial and error factor is pretty de minimis. It's pretty hard to conduct experiments on the universe itself. And yet more and more are we dependent upon qualifying sources of information for guidance. And so that's a perspective from which there are some issues that we're facing. Cosmic issues. Is the universe infinite or finite? The great discovery of 20th century science was the discovery and the realization that the universe is not infinite, it's finite. How long has it been there? All kinds of guesses. A very elusive science at best. More to the point, was it designed or simply the result of some kind of cosmic accident? It's really quite astonishing to see learned people come to very, very bizarre conclusions. Are there limits to size? How large is the universe? How small are the smallest elements? That may be surprising, what we've discovered about that. We speak of empty space. Is space really empty? Has time always been the same? Are there other dimensions beyond the four that we experience directly, the three spatial dimensions and time? Those are issues. So we're going to explore the boundaries of our reality, and that's going to be our primary epistemological challenge in this session. And we're constantly subject to illusions of various kinds. And these illusions can be colorful minor things, or they can be very profound issues that we're facing. So first thing we're going to try to do is develop a critical perspective. There are two concepts very frequently discussed in mathematics that we cannot find in our physical universe, surprisingly enough. One is infinity. We talk about it, we put it in equations, we can deal with it conceptually. Can we find anything in our universe that's really infinite? And the other concept that's just as elusive is a concept called randomness. Randomness. There are mathematical tests for a series of numbers to see if they're random or not. It turns out that if you're faced with designing a computer and you need a source of random numbers, that turns out to be a major challenge, because we discover there is no such thing as randomness. There are things that come close to randomness. In the computer field, you have what's called pseudo-random number generators, because a true random number turns out to be surprisingly absent from our physical universe. That leads to a whole field of mathematics called the theory of chaos. We're also going to talk a little bit about the existence of hyperspaces, fancy word for simply spaces that have more than 3 dimensions. We're going to talk about this to broaden our own personal horizons a bit here. So these two imputed concepts. The first is randomness. The professional term for this is entropy. You'll hear thermodynamics people others speak of entropy. Entropy is simply randomness in an absolute sense. And most engineers and scientists are trained in deterministic process. 2 + 2 = 4 always. 2 + 3 = 5 always, precisely. Those are deterministic concepts. In our real world, we encounter a field of processes that we call stochastic processes, where one or more of the variables involved are subject to randomness to some degree. And the whole field of advanced statistics deals with this. One of the frontiers of science called the design of experiments. How do you design experiments when you can't control all the variables? The major frontier, very powerful, critical tools involved there. The pseudo-random number area is an area that surprises many, because you think that you could always find a random number. Try it sometime. You might resort to the famous publication by the Rand Corporation, 100 million random digits. And it turns out even that, while it passes a number of tests, is not truly random. And that leads, of course, to a whole field of science called chaos theory that we won't spend time on here. But there are measures of information that we need to be sensitive to. We realize that there are opposites. If we speak of disorder and order, those in some respects are opposite from one another. We can tell when something is ordered, we can tell when something is disordered. You can take a deck of cards and you can see if they're in bridge order, for example, or if they're shuffled and totally apparently random. So disorder and order are opposites. Noise and signals are opposites. An engineer will speak of the signal-to-noise ratio of a receiver. The signal is the part you're interested in. It's the part that carries information. The noise is what interferes with that has no information in it. Music, the opposite of that would be cacophony. And I'm sure many in our audience would suspect that in today's music it's hard to tell, but I won't go down that path here. Chaos, absolute chaos in contrast to cosmos. The term in the Greek of cosmos means ordered, to bring order out of chaos. So on the left, on the chart here, we have randomness. On the one hand, we have design, deliberate design or intent, teleology, if you will, on the other. We call that which is on the left, disorder, noise, cacophony, chaos, or randomness. The technical term for that collection of concepts is entropy. The entropy is maximized on the left side. On the right side, we call that information. It's the opposite of entropy. Order, signal, music, design. It's information. It's interesting that these two, entropy and information, are direct opposites of each other in the information sciences. And we also discover there seems to be a law pervading every field of science in which information tends to get degraded. Through time, entropy takes over. In fact, that becomes one of the primary laws in thermodynamics, is that we always move towards increasing entropy. The whole universe operates as if it's been wound up and is in the process of winding down, where we have order going to disorder. We see that in our garages. We spend a Saturday cleaning up the garage. How long does it stay that way? We clean up our locker in school, or we organize our desk. We spend a half a day straightening it all out. And how long does it take before it's helter-skelter again? See, there's a trend, without the intrusion of some design, things will drift to disorder, randomness. We observe that in every field of our our endeavors. And it's interesting, the Bible makes reference to this. The lot is cast in the lap, but the whole disposing thereof is of the Lord. The way Einstein summarized this, Einstein said, God does not play dice. Do you know why? Because if he did, he'd win. He's in control even of the randomness. There is no such thing as a truly random event. So there's another concept that eludes us in our physical universe called infinity. We glibly talk about it in school, but where do we find it? Let's first explore infinity in the macrocosm, in the universe, in the large sense. And the great discovery of 20th century science, as I mentioned, is that the universe is finite, not infinite. And we have very finite boundaries. The initiation of the universe is known among some as the Big Bang, a singularity, and it ultimately will burn out and result in the ultimate heat death. All work is done by a temperature difference, and as work is done, that temperature difference decreases, and when the universe is of a total uniform temperature, no more work can be done, and the mathematical term would be ultimate heat death for the universe. See, in thermodynamics, we have three laws. The conservation of matter and energy is well known to most students, which says that you cannot create matter or energy. You can transfer matter into energy, energy into matter, but you can't create either one from scratch. In other words, first law says there's no way to win. The second law is the entropy law, the bondage of decay, that all thermodynamic processes are inefficient, less than 100%. There's some percent of the work that gets lost to the ambient temperature. And that's a very basic law of thermodynamics. The second law of thermodynamics, some people might rephrase that and say you can't even break even. There's no way to win, you can't even break even. The third law, many people are not familiar with, everything has a positive finite entropy. So the first law says there's no way to win. The second law says there's no way to break even. And the third law says you can't even get out of the game. But we'll focus very intensely on the second law before we get through here. Let's talk a little bit about thermal decay. Heat always flows from hot bodies to cold bodies. We experience that in many, many ways personally. If the universe was infinitely old, the temperature throughout the universe would be uniform, because heat would be always flowing to cold, and if it's infinitely large, you'd have a uniform temperature, and it isn't uniform, therefore it isn't infinitely old. This very simple observation tells you that the universe has an age. It's not infinite. And the universe had a beginning, and it's destined also for an ending for the very same reason. And that's what the Bible tells us, is that by him were all things created, that are in heaven, that are on earth, visible and invisible, whether they be thrones, dominions, principalities, or powers. All things were created by him and for him. And he is before all things, and by him all things consist. That word consist actually means sustains, holds together. The astonishing thing isn't just that the creation has been created, is that it is maintained. There's some very delicate balances that we'll talk about shortly. The book of Hebrews says much the same thing. God, who at sundry times and divers manners spake in time past unto the fathers by the prophets, hath in these days spoken unto us by his Son, whom he hath appointed heir of all things, by whom also he made the worlds, who being the brightness of his glory and the express image of his person, upholding all things by the word of his power, when he had by himself purged our sins, sat down on the right hand of majesty on high. Wow. Upholding all things by the word of his power. The need for maintaining the creation is something we're going to encounter as we get into this further. Increased hazards. Hopefully, with adequate supervision, nothing serious occurred. So as we matured, our next boundary was expanded to our homes. And there we had increased mobility and challenges. We had, again, hazards, our boundaries that we could deal with. In that environment, we got a little familiarity with acoustics, visual colors, touch and textures. Three-dimensional perception began to take place, basic motor skills to be able to reach and pick up and so forth. Then as we matured, our world broadened to our playroom. Our universe expanded within the confines of our playroom. So we began to have more discernment of things. We began to get introduced to rules and an order to our routine. We faced increased challenges of things that we could deal with, but also epistemology is simply the study of knowledge in terms of its scope and its limits. And how do we know anything? How do we learn anything? Let's talk about that for a bit. When we were very, very small and in a playpen, our world consisted of that playpen. That was So what we're going to do as we approach this topic, I'm going to call, for lack of a better term, Epistemology 101. We're going to get right at the basics of this.